Hello, my name is Bedard and I will be presenting a poster summarizing my research into the microstructural evolution of cold-sprayed aluminum 6061. This study utilizes a systematic series of heat treatments and a combination of advanced microscopy techniques to reveal how such heat treatments will affect the unusual microstructures seen in cold spray coatings. For the experimental procedure, thick aluminum 6061 coatings were sectioned into heat treatment specimens and subjected to heat treatments between 100 and 500 degrees Celsius for 2 hours apiece. Once treated, the specimens were thinned and twin jet electropolished into 3mm TEM foils to be used in SEM, EBSD, and STEM imaging. The aluminum 6061 powders used to build these coatings were processed to meet the mil spec standard. These powders are characterized by a spherical morphology with ridged surfaces, an interior network of thin film magnesium and iron-bearing secondary phases which delineate discrete cells. Clusters of these cells constitute a single grain, as seen through channeling contrast in BSC imaging and EBSD grain mapping. After cold spray deposition, these powders have formed a fully dense coating with properties similar to aluminum 6061 in the T6 condition. However, the microstructure of this material appears very different from conventional T6. The thin film distribution of the secondary phases has been preserved within the interiors of the prior particle regions. Severe plastic deformation can be seen on the prior particle boundaries. This deformation manifests in two microstructures: a squashed cell structure, where cells and grains appear to have been pancaked during deposition, and a recrystallized structure where cells are not readily observed, but fine equiaxed grains are revealed in EBSD mapping. Bright field STEM imaging has been used to observe the dislocation density of these different regions. It can be seen that the interiors of prior particles exhibit high dislocation densities, and boundary regions show evidence of dislocation-free, yet equiaxed grains. After heat treatment, three main microstructural evolutions are observed. Secondary phases coarsen at and beyond 300 degrees Celsius, with some degree of solutionization appearing to occur at 500 degrees Celsius. Grains appear to undergo recovery and recrystallization up to 300 degrees Celsius before dramatically coarsening at 400 and 500 degrees Celsius. Cumulative area fractions extracted from EBSD grain maps reveal that the initial coating microstructure is comprised of nearly 45% recrystallized material relative to the initial powder microstructure, and that jumps to about 85% of the area fraction after a 300 degrees Celsius heat treatment. And finally, at 500 degrees Celsius, there appears to be outgassing and pore formation in the prior particle boundaries. In conclusion, this poster is a summary of a systematic post-deposition heat treatment experiment on thick, cold spray coatings of aluminum 661. Three distinct microstructural regimes are defined within the gas-atomized microstructure: coarse-grained interiors, squashed cell boundaries, and recrystallized boundaries. And three behaviors are tracked with respect to heat treatment: secondary phase coarsening, grain refinement, and pore formation. Thank you for your attention.